meeting is being recorded.
Hi, this is Group 7, and we're going to do the midterm project update. This is Rajiv, Achyut, Varshik, Shivani, Prasanna, and Nikita. So, the project objective was to build an autonomous rover that could basically navigate itself across a difficult terrain or a path. It should be able to basically navigate, uh, uh, avoid obstacles, and it should be able to generate a map so that it can be used for further analysis. And the rovers, the one of the requirement was to make the rover modular, where you can modify the number of wheels or sensors or the orientation of the rover, so that based on the terrain you can decide which one fits the best. And we also need to have an object-oriented approach to build this project so that it's easier to implement this for the user. Uh, the current project status is that we were able to generate uh, we are able to generate the ROS world. We're able to design the rover similar to the GoPy-Go rover, which is the requirement that was provided. We were also able to customize the rover with different number of wheels. So we were able to add either 2, 4, or 6 wheels based on the requirement. We were also able to add a laser sensor to the rover. This sensor can be used to detect objects. We were also able to come up with scripts that could easily install ROS, Python, Gazebo, Arvis, and Slam, and thereby making the setup of the environment pretty easy for the user. And we were also able to control the user using command line inputs. So based on the inputs provided by the user in the command line, the rover would move in that particular direction. And we were also able to mount sensors on top of the rover. This is uh, a small image of how the rover looks in our environment. How that so over the course of the project, uh, I would say, like from the start, initially we did face quite a few issues with regards to setting up the environment and uh, coming up with uh, testing the basic script was pretty difficult, as the environment was not set up properly. We started off with using VirtualBox, Oracle VirtualBox, but no matter how much RAM was provided, it would we saw that ROS and Gazebo would not be working simultaneously. Hence, we moved to dual booting PC with Ubuntu, and we installed the environment where we had the environment installed from scratch on the dual booted Ubuntu. And from then on, we started taking steps and building the project. We were able to come up with a couple of test scripts, initial test scripts, which we used to uh, to ensure that the environment is run properly and that um, all of the all of the modules were installed properly, like Gazebo and ROS. We the test scenarios made sure that they were installed properly, and from then on we started progressing. And as a team, we used to make sure that we met regularly. We used to have Scrum meetings 3 times a week. We conducted sprint planning before each sprint, so that we made sure that the user stories that we selected and tasks that we selected were um, were in chronological order, I would say, and that we also tried to ensure that our sprint goals was in line with our product goals. We also conducted sprint review and retrospective after completion of each sprint. We would, whenever a sprint gets over, we as a team would sit together and discuss how the sprint went and whether we had any issues along the way. And if there were any issues, we discussed whether how we could overcome these in the following sprints and make sure that we do not have the same issues in the following sprints. Uh, Having these retrospectives really helped us over the past three sprints because it made sure that we do not uh, our issues and errors were not repetitive, and that once we face the issue, we wanted to make sure we never face the issues again. So I would say that sprint review and retrospective really helped us. Uh, we uh, we also created user stories with specific branches. We discussed each other's updates mainly over the meetings, just to make sure that everyone was able to proceed. Uh, the the Scrum Master, we had a Scrum Master every meeting, and Scrum Master would ensure that the the project was and he would ensure that there were no roadblocks, and if there were roadblocks, he would try to make sure that they were rectified. We also followed a good uh, code review where whenever a code is checked in by the members, the code is reviewed by the reviewers that were provided for that particular check-in before it is merged into the branch. This proved pretty helpful because we wanted to make sure that there were no there were no unknown issues from the coder point of view. Like for example, if the person who codes and checked in the code, it probably worked in his environment, and he thinks that what he did was right, but it may not actually be the right thing. So we had the other members review the code first before merging it into the main branch. Our plan for the remaining sprints is that now that we have a working rover whose control is in our hands, and we were also able to move the rover in every single direction and also mount sensors on top of it. The remaining uh, the remaining part of the project would be that we have to implement an autonomous that we have to make sure that the we have to make the rover autonomous, and that the rover should detect obstacles and move accordingly. Like if it has a obstacle in front of it, it should be able to dodge it and move in another direction so that it can proceed towards the map. It should also be able to map the surroundings of the rover based on the data received, which is that after it traverses through the map, we should be able to uh, generate a map in our environment for analysis. And it needs to make use of the sensors that are mounted on top of it for this. Uh, the we should integrating intelligence in the rover to navigate autonomously. So we should basically have some sort of intelligence so that the rover can make decisions as to which is the best direction to move in after it faces an obstacle, so that it moves to the map in an optimum way. And finally is the generation of the maze. um, the rover should be able to generate maze at the end of the traversal. So these are some of the statistics that we saw for our sprints up till now. So the first one, you could see a table where we have the lines of code. So we had three primary languages here that we use, which is Python, XML, and Bash, where we had 143 lines of Python code. Uh, we had 1,500, around close to 1,500 lines of XML code, which are basically the configuration files for the Gazebo world. And we also have 131 lines of Bash code, which is our scripts that are used to easily install and set up the environments like ROS, Gazebo, RViz in the user's PC. And some of the other statistics like number of closed points that we have closed till now are 23. Our backlog progress up till now is 36%. The number of user stories completed are 6, and number of tasks completed are 17. So these are some of the statistics that we saw until for our 3 sprints up till now. Thank you very much.